When we work with equations, we have standard forms of how we look at those equations. With linear equations, we have several of them. Today we're going to look at what's called standard form. Sometimes it's referred to as general linear form. So our objective is I can write linear equations in standard form, and we'll add in graphing with them too. So our standard form of a linear equation is ax plus by equals c. X and y are our variables for this. A, B, and C are numbers in this equation. Now we have some guidelines for A, B, and C. First of all, A, B, and C must be integers. And if they have a common factor, we need to reduce that out. So if they're all even, we'll divide by 2 so that we don't have that common factor. The leading term on this left side must be positive. Now what that means is either A or B must not be negative. So you're going to have one of them be a value other than 0. And then if you have that leading term, the first term on the left side being negative, we'll multiply every term by -1 to get rid of that negative. I'm also going to add on graphing. And the way we graph using standard form is that we use the x and the y intercepts. And how you do that, just as a reminder, the x-intercept is when you put in y equals 0. It gives you an x value, which is where it crosses the x-axis. And the y-intercept is where x equals 0. When you put in x equals 0, you get a y value. That's where it crosses the y-axis. So let's try these problems down here. This first one, it has 24 equals 8y. Notice I want the x and the y on the left side. Now there's no x term, and that's okay, but I want to get the y term on the left side. So I'm going to use this symmetric property where I can just have them swap sides on an equation. So the y's on the left, and now notice they have a common factor. I want to divide by that 8 so that they don't have that common factor. So if I do that, I get y equal to 3. When I graph y equals to 3, notice that that is the y-intercept. So I put 3 on the y-axis, and then I just draw a horizontal line there at y equals 3. Every x value there, as it changes, produces a y value of 3 on that line. Let's try to look at this one. This is already in slope-intercept form, but I'm going to convert it into standard form. So the first thing I like to do is get rid of the fractions. When there's a fraction, I'm going to multiply every term by 5 to get rid of that denominator. So I'm going to have a 5y equals 3x when I multiply it by 5, and then multiply this 2 by 5 and you get a 10. Now I want to get the x and the y terms over on the left side, so I'm going to subtract 3x from both sides and put it first. Notice it comes before the y term, so I'll put it in the front of the equation. And now, notice I have a negative in the very front of here. I want it to be a positive leading term, so I'm going to multiply every term by -1, and I get this equation. This is my equation. Notice that there's no common factors in the a, b, and c. A is 3 here, b is -5, and c is -10. That's my standard form of the equation. Let's graph using it. If I put in x equals 0, I'm going to get the y-intercept. If I put in x equals 0, notice I have -5y equals -10. -5y equals -10. Divide by -5, you get y equal to 2. So my y-intercept is right here at 2. If I put in y equals 0, that will give me the x-intercept. Y equals 0 means I'm left with 3x equals -10. Divide by 3 and you get x equal to -10/3. -10/3 is -3 1/3. So I'm going to go over here to -1, 2, 3 and mark out here -10/3, -3 1/3, and there is my x-intercept. And then I just connect those 2 points to have my graph. Now, just a reminder, since this is already in slope-intercept form, I could have started at 2 and then gone down 5 units and down 3 units and over 5, and I would have gotten the graph as well. or up 3 units and over a positive 5 units, and it would have given me the same graph of rise 3, run 5, or rise negative 3, run negative 5, and that would have given me the exact same graph. It's easier to graph in slope-intercept form if you start there, but this is just an illustration that if you're given the standard form, how to find the intercepts to graph it. Let's try this one. Number 3 here, notice there's decimals. The way I like to get rid of decimals is just multiply by, in this case, I want to get rid of 1 decimal place. Multiply every term by 10 moves that decimal over 1 place. So multiplying everything by 10, I get 0 equals 48 minus 8y, when you move that over 1 place, minus 6x. Now I want to get the x and the y on the left side, so I'm going to add 6x and add 8y to both sides. So I get 6x plus 8y equals 48. Now if you notice, all of these are even, and so we want to get rid of the common factor of 2 by dividing each term by 2. So we get 3x plus 4y equals 24. That is my standard form of the equation where a is 3, b is 4, and c is equal to 24. Now let's graph it using our intercepts. So if I put in x equals 0 to get my y-intercept, I get 4y equals 24. Divide by 4 and you get y equal to 6. So I'm going to go on my y-axis and graph a 6 right there. If I put in y equals 0 for the x-intercept, I put that in and I get left over here 3x plus 0 equals 24. Divide by 3 and you get x equal to 8 here. So I go on the x-axis out to 8 and graph that point. Notice how easy it is to find those points by just putting in 0 for the other one. That gives me my intercept, and then I'll just connect those points with a line to get my graph. I don't have to put it into slope-intercept form to graph using the intercepts. So standard form of linear equations is ax plus by equals c. We have to make sure we follow these guidelines for having a, b, and c be integers, either a or b not be 0, and then also the leading term being a positive. And if we want to graph those, we use the intercepts by putting in 0 for x, 0 for y, find out where they cross the axis, and we have standard form in the graph.